I'd like to continue the study of the graph of quadratic functions, but I'd like to change this equation from what I originally had it to y equals a negative x squared plus 2. When the number in front of the x squared term is a negative value, the graph of that quadratic function is going to open downward. Unlike the problems that we did prior in the previous video, when the number in front of the x squared term was a positive 1 here, those parabolas opened upward. But I said that quadratic equations might open up or they might open down. So by putting a negative sign in front of the x squared term, I'm going to cause this parabola to open downward. So let's go ahead and put some negative numbers in for x, and then some positive numbers, and I like to try quite a few values. And let's go right here and just see that whatever I do with x here, I want the opposite. That's what this means. This means a negative 1 times whatever x squared is. So a negative 1 times a negative 3 squared, which is a positive 9. Negative 3 squared is a positive 9. I multiply that by a negative 1 and I get a negative 9 plus 2 is a negative 7. So you have to be careful. I'm asking here for the opposite of that x value squared. So when I put a negative 2 in here and square it, yes, I get 4. But 4 times a negative 1 is a negative 4, and I add 2 to that, and I get a negative 2. I put a negative 1 in here and square it, I get 1. 1 times a negative 1 is a negative 1. I add 2 to that, and I get 1. 0 squared, okay, that's 0. Doesn't matter if you multiply it by a negative 1. You add 2 to that, you get 2. And then finally, let's do a positive number. Let's show all the work. So when I put a 1 in here and square it, I get 1. But then I have to multiply it by a negative 1. And then I have to add 2 to it, and I get a positive 1. Do you see this 1 and see that 1? When I put a 2 into this equation, I'm going to get a negative 2 out. When I put a 3 in, I'm going to get a negative 7 out. Let's go ahead and graph. So go to the left 3 and down 7. 2, 3, 4, 5, 6, 7. Let's go in our next ordered pair, left 2, down 2. So left 2, down 2. The next one, left 1, up 1. The vertex in this problem, x is 0, don't go in that x direction, just go up 2. So don't go anywhere in the x direction, just go up 2. And then to the right 1, up 1. To the right 2, down 2. And to the right 3, down 7. And sure enough, I do have the shape that looks like this parabola, but because of that negative 1 in front of the x squared term, it's going to open downward. Again, please notice no limits on what I got to put in for x, so the domain of this function is all real numbers. So I'm kind of grabbing two ideas here. I'm talking about what can you put in, and the range of this function is also all real numbers, but would you notice that the y values in this case, here's my y-axis, my y values are all under this number, all below this value, all below that number right there. Let's see, what is that number? Y is 2. So there are no values for y above 2. So y is less than or equal to 2. Want to show you another feature on the graphing calculator. So you put your y equals, we put in a negative, use the negative sign here, x squared plus 2, and I hit the graph key. There's the parabola that we just graphed. If I want to know what that point is, the maximum value for y, I can, and you could replay this video to learn this because we'll be doing it a few more times. If I go second calc, see above this trace key is the word calc, this particular parabola opens upward like this, so it's got a maximum point. So I'm going to select the number 4 right now. And it's going to say to me, hey Pat, this looks to be where the maximum is, but would you show me your left boundary? Show me a point that's to the left of that. So I'm arrowing to the left right now. And once I do that, I have to hit the enter button. So it's establishing a boundary. Now it wants a right boundary, so I'm going to move the cursor to the right. just so it's beyond that high point. And I'm going to hit enter again to establish the right boundary. And then I'm going to hit enter one more time because it says, do you want me to guess where that maximum point is? And I'm going to take it there, and it says my y value is equal to 2 at that maximum point. It says x is 1.15 times 10 to the negative 6th. Well, that's a very small number, or in other words, 0.00000115. So anyway, and again, don't forget, we could have set up our table to start at a negative 3 and go in increments of 1, and it could have given us all those values as well. So let's go ahead over here, and to be honest, I want to go ahead and put a negative sign in this problem as well. So I'm going to go ahead and call this y equals a negative x squared plus 3x plus 2. And I'm going to suggest that you go ahead and put this into your graphing calculator. So we've got a negative x squared. I'm going to arrow to the right to put in the 3x plus 2. And you know, I'm just going to look at the graph. I'm going to hit the graph key. Oh gosh, interesting. So it does open downward again because of this negative sign. I'm going to now go ahead and look, I can even see by my graphing calculator that I can, my x value here is about a negative 1, negative 2, negative 3. So you know I might start at about a negative 3 and go over to 5 for my x values based on this picture. So negative 3 to 5 I'm thinking. So I'm going to, let's see, give myself some room. I'm going to go negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. And it will do all the squaring for me and putting the negative sign in 3 times that value for x and adding 2 by going to that calculator. So again, second table set. I'm going to start it at a negative 3 because that's what I've chosen. I'm going to go second table. Now this is going to be a bit of a problem for me, so let's see, I've got some of these numbers written down. I'm just going to try to remember them. So when x is a negative 3, and that does make sense, it's a negative 16, a negative 8, I believe this one was a negative 2, and then 2, 4, 4, 2. Very interesting. Go back here. 2, 4, 4, 2. Again, let's plot some of those points. So when I go to the left 3 and down, boy, I can't remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to the left 3, down 12, down 16 would be about right there. To the left 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. To the left 1, down 2. X is 0, y is 2. X is 1, y is 4. X is 2, y is 4. X is 3, y is 2. So here's what happened. There's a point right here that is forming the vertex because this curve wants to go like this. And it wants to go like this because this is going to be my next point from here to here. And then see this point? I'm going to go ahead and mark that spot right there. I have to figure out that spot right there. And to find a vertex, a formula to do that is to take the opposite of b divided by 2a. That means, you know, this is my a value, actually right here. This is my a value, a negative 1. My b value is 3. And my c value in this quadratic equation is a 2. So my b value is this 3. So if I took the opposite of 3 divided by 2 times my a value is a negative 1, I'd have a negative 3 divided by a negative 2, which is a negative 1.5. That's where the vertex, I'm sorry, positive 1.5. So if I go over 1.5, somewhere right here is that vertex. Well, I'll tell you what. You go to this graphing calculator, you hit your graph key, and you tell it you want to find your maximum point because it's curving upward. You set your left boundary by hitting enter. You arrow to the right. and you hit enter. And then you hit enter again to ask it to tell you where that maximum point is. And it says when x is 1.5, y is 4.25. So this spot right here was supposed to be just a little bit over, but that's what's going to define. I better write that down. So when x is 1.5, y is 4.25. So I'm going to fill in this vertex. And finally, I'm going to say that the domain of this quadratic equation is all real numbers, and the range of this quadratic equation is all real numbers where y is less than or equal to 4.25. So right here, y is less than or equal to that 4.25, and I need you to be able to describe both the domain and the range of these quadratic functions. I'm going to let quadratics go at this point and let you work at those on your own some more, and we're going to start a new type of function in the next segment.